we found that velocity really matters a lot. The ability to validate as early as possible matters a lot. You don't want to like push a bad model to production. You don't want to wait until your final stage of like A/B testing in order to find out that something is not going to work well. So we found that like the earlier you can validate, the better it is.
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Biewald. Shreya Shankar was an ML researcher at Google Brain and an ML engineer at Viaduct AI, and now she's a grad student at UC Berkeley, where she wrote a paper that we all love here at Weights and Biases called Operationalizing Machine Learning in an Interview Study. This is a really fun interview. I hope you enjoy it. All right, thanks so much for doing this. I really appreciate it.
Of course, thanks for having me. I'm excited.
I think we've all been like watching you on Twitter or following you on Twitter for a long time, so it's exciting to meet
you. It's funny how it's like every now and then you like run into a Twitter mutual or whatever, and it's like, oh, like I know you, but I don't really know you, but I know you. Like,
totally. Yeah. We were actually doing a podcast with Sarah from Amplify Partners, and we both started talking about how much we liked your paper, and I was thinking, really, like I should I should just go directly to the source. But yeah, I guess maybe if you could tell us, before we get into your paper, which I really want to talk to in depth, maybe if you could tell us a little bit about your career and how you got excited about operationalizing machine learning.
Yeah, that's such like a buzzword, and honestly, like not the most exciting thing in the world. So it's kind of weird to think like how I got here. But I started out kind of like doing deep learning research, ML research in adversarial examples, because that was the like hot stuff in 2016, 2017. And I had this like moment of crisis when I graduated college. Should I do a PhD or should I go and be an engineer or go into industry? And I decided, okay, like I might as well go into industry because I'm trying to write my statement of purpose on working on robustness in machine learning systems and like ML system deployment. But I didn't really know what any of those words meant because I had no experience. So I went to a company, I went to a startup that was doing applied machine learning, and I was there for a couple of years. And that kind of changed the course of what I believe to be like some of the most pressing problems in operationalizing, I guess, these ML systems. It's a very broad topic. I define it as like anything that requires like having a machine learning system that's serving some output that people use on a regular basis that you don't want to shut down. And I think that's just like a completely different ballgame than just the ML research that I worked with. And there's a lot of problems in there, both technically and kind of organizationally, like the processes people use to, like on-call processes, things that people do to ensure reliability of their systems. And then, of course, the tools, the principles and techniques. I found myself really going back to like the databases and data management world in terms of like, how do I create these systems so that a bunch of data scientists can train models? And that really led me to, I think, doing a PhD in databases, where a lot of these problems a lot of these like ML ops problems can be recasted as traditional data management problems.
Interesting. So, yeah. When going back to, when you got your first job, we hear about this a lot. But what were the biggest surprises about machine learning in practice versus studying machine learning in school?
I think I had a nice trajectory of surprises because I started out kind of as the first ML engineer, and then we grew like, I don't know, like 8x, 9x in my time at the company, and we hired more ML engineers and more data scientists. And my first surprise was that training the model itself, like that whole experimentation to first model, is a process that you don't want to replicate with as much human labor as you do in the initial experimental stage. Like when you deploy it, like that retraining, that kind of component, you kind of zoom out on your entire pipeline. You want to automate that, and your human attention doesn't go there. It's how do you glue together that model in relation to all of the other stuff you have. So that was like one nice realization that I had. And then after that, I stopped spending so much energy and time modeling itself for the sake of modeling. Another realization that I had was when you have multiple data scientists working on the same kind of model or prediction task or pipeline or whatever you want to call it, all of a sudden, like, you need some sort of processes to make sure everyone is on the same page. Like, if I try some sort of experiment, or I have this like domain expertise around like, hey, this set of features probably won't work well, or this source of data is corrupted, so don't try to make features from that. How do I like share this knowledge in a way that's not like a stream of thoughts on Slack? And how do I keep this up to date as people come and leave the team? That happened a lot at my previous company before grad school. So that there's like a lot of these like small problems that kind of built as we grew organizationally, as well as grew in terms of the number of customers we were serving, the number of ML applications we were delivering, or predictions we were kind of serving to different people. And yeah, there was so much. I don't know how to give you a succinct answer to that.
Well, so it's funny because you've also had the opposite experience too, right? Like everybody talks about, the shock of kind of going from academia into industry, but you actually went from industry back into academia. Were there any surprises, or like sort of like, misconceptions that you saw going back into the academic world?
I think it's different for me because I also switched fields. Databases has been machine learning has also been around for a long time, but the kind of venues that have been popular in databases have like been around for a while. The norms are a little bit more well-defined, and they're not changing as rapidly as the ML research norms. The community isn't growing at the scale that ML research is growing. So in that sense, I felt like I was kind of walking into a completely different territory. And I think what I really like about the database community is they're very open and accepting of new ideas and new paradigm shifts. And I think it's because they've seen it multiple times before. They've seen it like SQL to unstructured data, or structured to unstructured data. They've seen it from like transactional systems to like OLAP systems. And now they've seen like web scale, all sorts of stuff, like the MapReduce era. Maybe that's still going. I don't really know. So in that sense, I think they're very eager and receptive to work in this kind of ML systems or data management for ML space, which I felt that at traditional ML venues, it was almost like you need to like train models in order to have your papers accepted. If you weren't training training models or like doing model inference, then is this a research paper? I don't know. Like I think database is just like a better home for kind of the work that I'm doing. Not to like diss on all the model training work, of course, but
and yeah, why is that? Is that because you sort of like you care about sort of practical real world applications? Is that a good summary, or why?
Yeah, I think there's a lot of problems around operationalizing models that are data management problems, and when you do research in that, like what venues are going to accept that research? Yeah. I'm not necessarily training models in this research, so it's less likely, I think, for ML venues to accept this work. And I'm also borrowing a lot of ideas from databases around how I think of models, how I think of provenance, how this can be used kind of to solve a lot of like observability problems, things like that.
Well, so then, you wrote this really fantastic paper, which we'll definitely link to. I was almost thinking maybe we should make it required reading before listening to this podcast so we can kind of get into the details. But yeah, you wrote this paper on operationalizing machine learning, and you went out and interviewed a whole bunch of practitioners and kind of like summarized the field, which is something that I always try to do. Like I almost feel like this podcast could be called like operationalizing machine learning. And I thought you really put things in a like really well structured, really interesting and surprising results that showed that you were really getting deep with the people you were interviewing. But I guess maybe before we get into it, could you maybe summarize the kind of key findings of the paper, and then we can, for the folks that haven't read it, and then we can dive into the nitty gritty.
Sure. So we interviewed around 20 practitioners, and the criteria was that they have worked on or are working on a model that's being used in production So basically, it's serving some predictions or some output that customers are using, and somebody will get an alert if the system breaks. Like, that's kind of our definition of production. And we interview people across company sizes and across applications like self-driving cars, banking, whatsoever. And we found, we looked for common patterns across people's interviews. We found 4 kind of high-level stages of their workflow around experimentation, like the evaluation and deployment, monitoring and response, and then data collection, which wasn't often performed by the ML engineers that we interviewed, but it was like a critical part kind of the production ML pipeline. So we identified these 4 components, or these 4 stages, and then we also identified kind of what are the kind of variables that govern how successful their deployments will be. Like, what are the things to think about whenever evaluating tools to use in each of these stages? How do I know if I'm on the right track to a successful deployment? And we found that velocity really matters a lot. The ability to validate as early as possible matters a lot. You don't want to like push a bad model to production. You don't want to wait until your final stage of like A/B testing in order to find out that something is not going to work well. So we found that like the earlier you can validate, the better it is. And then finally, the last V is versioning, which is how do you manage all of the different versions of models that you're going to have as time goes to infinity. How do you think about kind of all the edge cases or corner cases that your system must respond to? And maybe that's like slapping on a different version. If you come from this customer or you come from like this population, we'll give you this version. And yeah, like managing that, right, is like a pain point. So that's kind of the high level finding.
And so I guess, you obviously have a fair amount of experience in this already, like having kind of done this job yourself, and you're pretty active on Twitter and kind of in the conversation around this for quite a while. Were there parts of what you heard that surprised you?
Definitely. And selfishly, I think I conducted this study so thoroughly and like as like a research thing that took like 1.5 years that we kind of did on the side. I did this because like I was so afraid that I was leaving industry and going into academia and then going to go into a bubble and try to build systems for people and not know what I'm doing or whether this is useful. And what I did not expect was to just like kind of change my research agenda and direction. And one concrete example of this is distribution shift. I used to believe, well, it's maybe a problem depending on how you define it, but the idea that if you have this static model in production, like a static set of parameters or a function that's being called on some features, and these features are changing, time is going on. At some point, right, this is like the classic view staleness problem in databases, right? You need to refresh your views to keep up to date with the underlying data. If you think of a model as a view on a table, like the same thing exists. But I think a lot of the ML literature, or even things that I'd been thinking about, are how do I make my views like robust to these, I don't know, changes in the underlying distribution. And in practice, like, sure, that's like great, but if something as simple as recomputing the view or retraining the model solves my problem of staleness, then why don't I just do that? And you'll find that at these like very large organizations like Meta, Google, Amazon, etc., that they're simply retraining their models like 6, 7, 8 times a day, or even every hour. And distribution shift is not their problem. In this setting, when you're retraining all the time, like retraining on corrupted data becomes a problem. So how do I make sure that my data is clean and corrupted? How do I identify when to block a retrained model from being promoted back to production? Like all these sorts of problems. It's like, oh, these are very interesting research problems, but this is not what I thought of distribution shift to be. Hopefully that answers your question. I could think of others.
The people that you were talking to, were they kind of like individual contributors building models? Is it more like managers? We often see like a separate ML ops team that's sort of doing the infrastructure while other people are kind of doing the training. Like who were the kind of folks that ended up in your study?
We required that everyone was an ML engineer, like responsible for a model or like pinged when the model predictions are bad or someone's complaining at some point in their career. Some of them had switched to the infrastructure building side. Some of them had become managers. I think 2 of them had become managers. And that's like written in the paper. But everyone there like acutely knew what it was like to have like put a model in production and somebody complained about the predictions. And that's really what we wanted to drill into. Like, all right, it's so like, what did you do to fix this? What does your team do to fix this? Like simply retraining the model often fixes it like 80% of the time. These ML engineers have so much on their backlog. Like if they can kick off a retrain and get to something else on the backlog and it works 80% of the time, that is going to be the solution. That is the best solution. I feel like more ML researchers should know this, but maybe I'm biased.
Were these people mostly doing kind of unstructured data? Like one of the big dichotomies that we see is like structured versus unstructured, where like unstructured, you often get more, kind of neural net techniques. You get, bigger models. You get almost like a totally different stack in many cases. Did you observe that too?
Definitely we talked to some people who had very image heavy, like self-driving cars or autonomous vehicles is a good example of this.
For sure.
And they're definitely using neural networks. I think when drilling though into like data quality, and this kind of like data management, I think people tend to think about like relational data management, like how do I manage the embeddings or how do I manage like tuples? I don't know if we've like gotten to the place where we're thinking about like traditional data cleaning and data quality in terms of like images or like other unstructured data. But we didn't focus the interviews too much on that.
Were people doing a lot of exploration of features? Like did feature stores show up much in your interviews?
So we explicitly went into this not wanting to hit the buzzwords, just to see what buzzwords would come out.
Totally.
Feature stores were almost never mentioned. So
interesting. Why do you think that is?
I think people thought about the idea of like a feature table or a feature service, but very few people said the term like feature store. What mattered to them was just like having features that were available for them to query. And like oftentimes at organizations, it just happens to be a cron job that's like populating features. Obviously not at like Meta, they're not going to have like a Postgres table of features, but in a lot of like mid-sized cases, mid-sized companies, where you can have Postgres table of features and you can have a cron job that recomputes features every day, and it's fine. And I think it ends up going back to this like view staleness problem, right? Like how stale does it need to get for your business to experience some like performance hit? It's not like, I don't know if like you need to be computing them on demand all the time. Yeah.
I guess I love your your kind of simple categorization of like data collection, experimentation, evaluation, and monitoring and response. I guess did it feel like of those categories? I think you said the data collection was usually like a different team. But where was your where were your respondents spending most of their time, and where do you think they felt like the most pain was?
Because all of the pipelines that they talked about were deployed or like already in production, people did not focus on experimentation as much. I imagine that this is not representative of the ML community at large. I think there's like a lot of people who are still working on getting their like first production pipeline out there.
Just to be clear, none of these questions are leading. We're not.
No. I just want to say, like, this is like definitely a biased subset towards like production pipelines. I think the evaluation and deployment, actually, I think monitoring and response, it's hard, 50-50 on those. Just based on like the annotations of the interviews that we did, or like the codes and how we group them, it was very 50-50 on those two. And they often like link into each other. People will talk about like problems with monitoring staged deployments. So does that fit in monitoring or staged deployments? I don't really know.
Totally.
But I think it's definitely like a big pain point, evaluation and beyond.
And I guess one of the key findings here is that kind of monitoring for data corruption or sort of catastrophic errors is more important than monitoring for data drift. But you'd sort of imagine that monitoring for, data corruption would actually be kind of a lot simpler, right? Like why is that? What makes that so challenging to do in production?
I'm writing a paper on this based on some work with Meta. But in the limit, like people only add features to a model. They don't remove features. So what happens is these models ends up getting like hundreds of features to thousands of features to 10,000 features. So that's one thing. You've got models in production with tens of thousands of features. Another thing is that people are coming and going in these organizations. Like the ML engineer who built the model does not exist at the company anymore. And the model is still in production. Okay, so couple that with existing like data monitoring or data cleaning solutions, which is defining schemas for all of my features, like bounds, acceptable values, types for each one of them. Great. Who's going to do that and maintain that as these feature tables as these pipelines evolve? I don't know. The other thing is, because you have so many features, the probability that at least one record and one column is corrupted is so high. And then you get this problem, right, that we talked about in this paper of like just the straight alert fatigue, right? It's so painful. Like at the end of the day, it doesn't matter if just a couple of records are corrupted in one tuple. In one column. The problem is like, again, when does it get so bad that it brings down the business? And how do I find that pretty precisely?
It's funny. Yeah. I'm like nodding, and I've like lived this myself, like many, many times. That's why I totally agree. But I'm actually kind of thinking if I hadn't lived it, it might not be obvious, how this happens. Yeah. Is there like a concrete story maybe you could tell about like how a feature gets corrupted in production and the havoc that it causes?
Yeah. Okay. I want to I feel like this is like a question where people will attack me for any answer. Like if I give an example of like a Meta or a Google, they'll be like, oh, but not every company is a large company.
Well, I mean, but I think the story just sort of illustrates the chain of events. Not that, of course we're all so smart that we never have bugs, but.
Sure. I think I'll give one example at my previous company.
Awesome.
Which like I lived. So we had like features were generated from different sources. And when I say different sources, it's not just like weather data or whatever. It's like different clients have different data. And then also we have like different data pipelines that are like repeatedly pulling from Snowflake or repeatedly generating features. And oftentimes these pipelines will fail because like maybe there isn't enough resources or like there weren't spot resources available in US West. I don't know. Like things will happen. And these things will all be null. And will this corrupt model performance significantly to where I actually see a regression? I don't know. But this happens a lot. It also happens that like some of my clients, like they send me data every day. And like one day they send it in a CSV or Parquet. One day they switch the order of the columns. Like a totally reasonable thing, right? But again, impacts a subset of tuples, subset of columns. I could name a bunch of these. I think this is pretty generalizable to most orgs.
Totally. Um, I remember at my first job, all the features, for some reason, like there's no technical reason this is necessary, but someone started just like naming each feature column with like 4 letters, so, like literally like 4 letters for no reason, you know? And so then like people just kept like doing it. So like all the feature names were like just like really like compressed like word. So
Yeah,
basically at
stuff
some
like
point
that.
like no one knew what they meant. Like it was nuts.
Yeah, the stuff like that like really just like makes it so hard to go back and trace these like bugs. Like, why did my model regress 2%, for example? Like, oh my god, there would be a laundry list of reasons why. Just to even go there and try to investigate why would be like a nightmare.
Well, I guess though, if you're the people you talk to are just constantly retraining over and over, that actually might be one way to kind of avoid data corruption, like provided the way that they collect the features is the same as how the features get loaded into the model in production.
Yes and no. Suppose I retrain every hour. And when I retrain, I just like fine tune my model on the last hour's data. I split that into training, retraining, and then I split a little bit of that into validation. And my criteria for passing is like it has achieved like reasonable performance on that small validation set. Suppose that whole hour of data is corrupted. It might just be the case that like, great, like on this corrupted data, like because I trained on it, like I performed well on the validation set. Amazing. Same distribution. Put it back in production, and then somebody fixes the bug, and all of a sudden the performance changes, right? Because that snapshot of data was different from previous snapshots or future snapshots. So I do think that there is this still data corruption problem. And the challenge is in identifying the corruptions at the time scale that engineers react and respond to bugs. So you don't like put models in production that like won't do well on future data.
So I guess one of the little gems in your paper is the controversy. I forget exactly how you put it. Like you said, Jupyter notebooks are quite controversial, or quite a bimodal distribution of responses on that. I'm kind of curious your take on Jupyter notebooks.
So I think my take is a little bit biased. I'm not old enough to have lived the history of data management tools like spreadsheets and whatnot when they came out. But from my like reading of like old work, it seems that these quick and dirty prototyping data tools were used to tell stories and have primarily been used to tell stories regardless of whether it was done correctly or not. And I think that this is like the case for a lot of data tools. Jupyter notebooks are not really an exception. So while like if I want to start a company around like my opinionated, like I don't want errors and I want like no one's allowed to use Jupyter notebooks, like I think that's just an opinion. It doesn't. I feel like it's completely useless to go and try to like prescribe a philosophy to the industry that like has a pattern of using these data management tools.
Oh, that's kind of interesting, because I actually feel like you're kind of putting yourself in a place where lots of people might come to you and be like, "Hey, Shreya, like, what should I mean?" People come to me all the time, and I think you're more qualified to say, like, you know, how should I set things up? Like, should I be letting my team use Jupyter notebooks? And I guess if someone asked you, am I hearing you right that your answer would be no, don't use Jupyter notebooks?
Oh gosh. I think it really depends on the application of, or like what company I'm trying to run or what team I'm trying to do. What are the like engineering predispositions of the people on the team?
You're turning into such an academic. Like, I love it.
I'm sorry. Like I can't give it. I can't. But I think that's the point. Like, so one thing about this paper is that like it's an academic paper, so we can't like write all of our opinions in there. But I really wanted to like drive home the point where it's just like, the reason that we think that people have these conflicting opinions is because they have different conflicting priorities, right? Like, do they want initial velocity to be a higher priority than validation? That's like personal, or that's organizational. I think those values are different for everyone.
I guess that's fair. I would think that, kind of over time, your priorities would naturally shift. Especially I guess as like a startup founder, in the beginning, you don't know how useful the model is going to be. You don't know if it's really going to see the light of day even. And then kind of over time, you really want to start to like nail things down and you worry more about the downside risk.
And then you have to like account for this infrastructure or like even like transition in your organization from notebooks to whatever, if you want to deprecate them. Like we interviewed one engineer who they had this like whole their quarterly goals or whatever were to get evaluation of models out of notebooks and put them in like this standard system. It didn't matter what like CI/CD tool or whatever, but the whole point was just like get this in a standardized system so that people would stop like running notebooks as a way to show that, and like everyone a different fork of the notebook. I don't know. I feel like stories like that just make me like, oh my god, like no one is working on ML. No one is working on the direct company objective because they're like fighting their infrastructure battles and like, I don't know, dealing with all the tech debt that they introduced from having the notebooks. So what is the trade-off? I don't know.
Were there other stories like that or like themes like that where there's like kind of a consistent regret of something that people did in the beginning that they now can't get rid of when things are in production?
So the people who we interviewed that were like more senior in their roles or had been around for longer kind of just accepted this. It's like, oh yeah, like, organizational turnover is a thing. Tech debt is a thing. Like, our goal is not to remove it completely, but it's like, how do we like keep shipping new things, keep old things up and running in the face of all of the tech debt? And I think that's a more interesting question to me. There are a lot of like one-off stories. I can't think of any off the top of my head that were specific to this like Jupyter notebooks. I guess there was one other anecdote where somebody spent like 3 to 6 months trying to reproduce some Jupyter notebooks, just to like make a point that like they shouldn't use Jupyter notebooks within their organization. I don't. And then their organization had this like push to like, this was more of a smaller company, but to get rid of notebooks or notebook usage company. So again, it's like just so polarizing.
That's a little funny. I mean, my honest experience of Jupyter notebooks is I think they're kind of delightful, but I didn't like. I'm like a little, I predated Jupyter notebooks, so I was doing like most of my like hands-on research before they existed. So I'm just like a little more comfortable in the command line. So I always feel like a little ashamed that like I'm not like sticking with the new trends, but it sounds like there may be a backlash coming to these notebooks.
I think it's also different. Like different people are different. I'm the type of person where somebody hands me a Jupyter notebook or like something and like, here are some results. I will be like, and show me how the results got here, because I will be paranoid at every step of the way. We talked about this in the paper, like this like paranoia, the sense of paranoia we all get. And the same thing is like, at least the same thing is true for me when it comes to like SQL queries. Like if you give me a SQL query, I want to know like everything that's in I want to like re-execute that SQL query so that I get the same result. Same thing with spreadsheets. Like give me the spreadsheets. Don't take the like screenshot of the spreadsheet and save it to me. That's totally personal. I think people are different in their philosophies of how they do this. Which probably affects stuff.
Interesting. I guess what is your takeaway on the whole space of ML tooling, which obviously, I run an ML ops tools company. So, but please, like, you won't offend me with your answer here. I'm really curious, kind of like, did you feel like people were using tools, or were they kind of like rolling their own tools? Did you feel like there's like gaps and like missing tools? Were you inspired to like, start a company in the space from the feedback that you got? I think it'd be hard for me to contain myself, but I'm curious what your overall
there's
takeaway is.
There's a lot of companies that could be started from the paper, but anyways, I I thought that the 3Vs thing made tools, or at least the viability of ML tools, make a lot more sense. Like experiment tracking, weights and biases is a great example. It really 10x's the velocity experience within experimentation, like truly 10x's it, right? No longer do I have to go copy paste my results into a spreadsheet and back and forth between training script and spreadsheet, right? Like it's just nice, great velocity experience. I think most tools that I've seen in this space don't really 10x in any of these dimensions.
What are the dimensions for someone who hasn't read the paper?
Like velocity, validating early, and then versioning. Like versioning is an interesting. I think there's a lot of people trying to work on reproducibility, and related. I have thoughts on reproducibility, but like related problems. But it really needs to be like a 10x experience in comparison to what people used to do with versioning, or with one of the variables. And I think that that's really hard to do in the ML tooling space. People are really trying to find that. People are, at least in my experience, like simply trying to throw like software engineering principles at ML workflows and hope they land. But I don't, if it doesn't really like push one of these variables, then it's unclear that, to me, it's a successful tool. Like this ML monitoring is also a really interesting space because people do care about the concept of validating. Like I want to validate that my predictions are good before somebody complains. But it's really unsolved. And like, how do we do this precisely? How do we not give people alert fatigue? I think people will go to a lot of extents to like the friction of integrating an observability or monitoring tool can be pretty high if you get results, but people are not getting results.
And okay, I guess what are your thoughts on reproducibility?
I think there's an interesting paper. Gosh, I don't remember off the top of my head. This is bad. I should know. But they pose that, hey, exact reproducibility is often just like not achievable in a lot of ML settings. Just because like when you're a data scientist at a company and you're launching a job, like, yeah, sure, you can control your random seed, but like you can't control the infrastructure or like the GPU provision to you, is like the underlying data that you called from, whatever. Like what matters is getting like some percentage wise, if you're trying to reproduce a model, like I want to get the same accuracy or a similar accuracy. I cannot rely on getting the same model parameters. So this notion quite like, I guess, is a little bit orthogonal to like all of the provenance and like instrumentation of ML workflows to get exact reproducibility. I'm not sure like how feasible that is like in a Kubernetes environment, for example, or like larger scale infrastructure.
Wait, so to summarize your position, is it that reproducibility is impossible?
Oh, I think we just like for reproducibility tools, like we need to rethink like what it means to get like reproducibility, like tracing, for example, tracing like a data scientist workflow, saving the exact artifacts. Is that what matters? Like, what is it that truly matters with reproducibility? If I have the artifact, but I can't reproduce that artifact, or like if I logged artifacts at every step of the way, but I can't reproduce them, does that help me? I feel like these are kind of questions that I don't have the answer to off the top of my head.
Okay, I can't help but like weigh in on my own thoughts here because people ask me about this a lot. I guess I think I totally agree that reproducibility is kind of like a much less of like a binary switch than people realize. Like I think there's like lots of things you can do that are like increasingly annoying to make things like more reproducible. And I kind of think that and I think there's a real cost, so you shouldn't necessarily do everything possible. But I do think most people would stand to gain from going like further along that like, you know, reproducibility trade-off curve than they're doing today. So I always try to explain that to customers actually of like, hey, you know, we try to make it easy to like save a lot of stuff so that you have, you know, because like we're most people's starting place, at least in my experience, is like zero reproducibility. Like I'm talking about like a model they made 6 months ago. They couldn't even tell you like the state of the code when the model trained. Like forget about the data that went into it. And so it's sort of like, I think every step towards reproducibility is going to make your team function better. It's going to help you with governance. Like there's so many reasons you actually would want to do it, but I think it is incredibly expensive to get perfect reproducibility, like you're saying.
Yeah, I like your definition of like kind of pushing further along the reproducibility axis. Then the question becomes like, okay, what are the markers on this axis? I don't have an answer to this. I'm curious.
Well, if that's your next paper, I'll definitely you can come back and tell us about it.
Not my next paper.
You had kind of another kind of interesting. I love all the different kind of frameworks that you're introducing here. I feel like you're really good at sort of summarizing stuff and putting them into simple CEO style frameworks. But you also have this notion of like kind of like layers that tooling lives at, right? Could you maybe talk a little bit about that?
Yeah. So this terminology caused a lot of controversy within the authors trying to come up with the names. I don't think anyone loves the 4 layer names that we have made. But so I don't know if they're the best, but we kind of think about the stack of tools that an ML engineer interacts with in frequency of like most frequency to least frequency, top to bottom. So at the top is this kind of run layer. Then we think about a pipeline layer. Pipelines are made up of multiple components. So like, I don't know, feature engineering, feature generation, training, train test split, like whatever components you want to have. And then at the bottom, like underlying is like all this infrastructure that people use, like their compute, like what is the workflow kind of built on top of. And we kind of notice or observe that when people want to make changes to their workflow, it's the easiest to do in the run layer. It is much harder to kind of like kick something out of the infrastructure layer and replace that. And it happens in certain companies, but it's like a big like organizational effort to do it. Like they all have many meetings. It's true. It's true.
What would be an example of a change someone might make at that layer?
Which one? The infrastructure layer?
Yeah.
Yeah. I think one example is like moving from like GPU clusters on-prem to cloud GPU. That's one big one. Another one's like introducing like an orchestrator for these servers, like Kubernetes. At least these are things that I personally experienced also at my previous company that I was at. And like even like the pipeline layer is super annoying to like make changes to. Like if you have like Airflow, Kubeflow as your orchestrator, like it is such a pain to migrate that. Like they like every, I don't know, like planning meeting will be like, and should we migrate? Yeah, we know we need to migrate. Oh, but it's gonna be so much work. Yeah, I know. Like stuff like that where it's just like if I'm a tool builder, I really don't want to get into that space because like I'll have to sell so hard to people to switch a tool at that layer. Yeah. So I guess in that sense, like one thing we found is like the open source tools that could be integrated at the run layer. Like Weights and Biases is actually a great example of this, where it's like, one engineer can like simply integrate that into their pipeline and it will be useful for multiple runs of that pipeline. Like they're not replacing the pipeline layer tool. We found that those were the tools that the, I guess, interviewees were willing to adopt the most. But I feel like we could have done a lot more in kind of like running a survey, a quantitative survey or something on this. Maybe that's like somebody's future work or whoever's interested in that. So I'm hesitant to like prescribe this as like the end all be all.
Prescribe the layers or prescribe like specific...
Oh yeah, the layers and the idea of like if you're trying to build an MLOps tool, don't build for don't try to like I don't know, replace TensorFlow or PyTorch. Those people have their moat. People are not going to rewrite all of their deep learning models in your framework. Maybe unless you build,
what if it's JAX? Maybe they will
what if
do
it's
it.
Yeah, then I don't want to get into again. I don't want to get into like these like debates, but it feels like one layer is easier than the other.
Well, okay. I mean, I really appreciate your kind of open-mindedness about like sort of like workflows and setups, and I totally share it. But here we are on October 2022, and like somebody like listening to this podcast, they probably like I think what a lot of the people like listening to it are like looking for is actually some help in like navigating, like there's just so many options for tech stacks. Like there's like, like SageMaker is not the same as Vertex. It's not the same as Azure ML.
Totally.
Like where would you start? Like let's put on the example of like, like a startup CEO kind of just getting product market fit, like doesn't have like a lot of resources, but ML is like important to them. Where would you recommend him or her to like begin their looking at a stack, or how would they think about that?
I will say a stack that is tried and true. It may not be the best stack, but I would recommend like getting like an AWS account or something, having some easy to cluster setup. If you're working with large amounts of data, I have my qualms about Spark, but I mean, Spark is useful and people know how to use Spark as a query engine on like large amounts of data.
Okay. I can't live aside. What are your qualms about Spark in a nutshell? And then we can continue.
Man, I'm like sitting in the lab where Spark was invented. I don't like the idea, so I think I subscribe to like the database community of like MapReduce as a philosophy of processing large amounts of data is not great because it forces the application developer to reason about record level problems. Like if one record is corrupted, how do I handle it? It also forces the application developer to reason about consistency. Like if I'm controlling the parallelization, right? If I'm programming like a Spark job or MapReduce job or something, I shouldn't have to do that if I'm a data scientist. I shouldn't be controlling these kinds of variables. And this is like what DBMSs are really great for, is like they abstract away these like parallelism internals. They abstract away like ACID, how people achieve ACID. The DBMS is doing that. So in that sense, I'm not a really big fan of this like kind of MapReduce style of work. It's also like kind of inefficient to like have like a SQL layer on top of a MapReduce layer, on top of whatever like the storage is. But that's like a separate thing aside. That's not like a really user experience thing. I like as an aside, like I think it's interesting, like the whole DuckDB, at least explosion that we see going on of bringing like these kinds of large scale data queries back to the DBMS. I'm curious where that's going to go.
Interesting. All right, but I totally derailed you. But so you're saying like kind of AWS, like EC2, start there.
Like get an EMR cluster for Spark, and like have some way for data scientists to interface with these machines. Kubernetes, this might be a lot, but some way for them to like, I guess, access the machines that you have in your computing cluster. So that's one thing. I think another big thing is like once you get to like production level stuff, right? Or if you have data pipelines at your company, you need to have some sort of workflow scheduler, something to define like a DAG and then execute those DAGs. Airflow is like really tried and true. I know a ton of people hate it, but it will work. It is also known to work in cloud-based settings. They also have a nice Python DSL to be able to define DAGs. They have a nice UI to trigger the DAG. They have a nice UI to backfill the DAG. So I would say that's good enough. And then on top of that, I think like people, I don't know, hire a good like data science lead, ML engineer. to do the ML stuff.
Do you have any advice on hiring a first ML engineer or data scientist?
I wish. I almost want to say don't hire somebody right out of college, but I was hired right out of college, so I shouldn't say that. But like the problem with that was I didn't know anything. Like here I was like writing deep learning models in Jupyter Notebooks, saving them to S3, and then like telling other people to like read. No, that's like a terrible workflow. Or a terrible workflow if you want multiple people to collaborate on the same thing and share learnings effectively and also scale. I think people who have data engineering experience tend to like at least think about the right, not just terminology, but concepts. Like SLAs are a good example of like ML people should also be thinking about SLAs. Like what is a minimum accuracy that my product should have before somebody complains about the predictions, like stuff like that. How do I schedule things on a recurring basis? A lot of about pipelines can be casted as like data pipelines, right? So I would hire somebody who has data engineering experience for sure. Ideally, hopefully someone who's trained a model, but I honestly think that's less relevant than having the data engineering experience. I feel like I've talked to so many people who have ML experience, but then don't have any software engineering or data engineering experience. And that's like really hard, right, to convert when you're starting a company.
Makes sense. Well, we always end with 2 questions. I want to make sure we get them in. So
Sure.
I guess one is, what is a underappreciated topic in machine learning broadly?
Machine learning.
Like if you were to go back into machine learning and could investigate something, where would you be like wanting to look more?
That is not a data management problem. This is an exercise for myself. I think the idea of interpretability, but I think of it as provenance. Like the influence functions paper is interesting. Was like if I have a image and I have a prediction of this image, what are the training examples that like most likely helped the model get to this image? But techniques to do this are kind of computationally expensive or are limited to like a single point in the training data, or require like a full pass through the training set for every. Like I think there's a lot of work that can be done there, kind of on interpretability, but not of the model, but like explaining how a prediction got to where it is based on the data that a model was trained on.
Interesting. Do you remember the name of that paper? I'd love to put it in the show notes.
Understanding black box predictions via influence functions.
Nice. And then I guess the final question, which you are incredibly qualified to answer, I think, is when you look at the life cycle from kind of research paper to running successfully in production, where do you see the biggest bottleneck or the most surprising bottleneck?
Evaluating if this research or this new idea actually provides a worthwhile gain over another solution. Is there something off the shelf? Is there something baseline that can get something very similar or get a performance that's very similar, but not have to go through this headache of like understanding the new thing and implementing this headache? I don't even think we have frameworks to think about this.
So you're just saying it's painful to try all the different things and see if they actually work?
Yeah. It's like, or do we even need to try all the different things and see if they work? Like, if I'm a practitioner at a company, when do I actually pay attention to some ML research development? When do I actually integrate it into my system? I don't think that people have a framework for thinking about this. So at least I haven't heard of a big one.
All right. Well, thank you so much for your time. That was super fun. I really appreciate it.
Yeah. Thanks for having me.
If you're enjoying these interviews and you want to learn more, please click on the link to the show notes in the description where you can find links to all the papers that are mentioned, supplemental material, and a transcription that we work really hard to produce. So check it out.